Warren, take it away.
Okay, my name is Warren Ohm. I'm with a company called NATO Mist here in Chicago. We manufacture steam vents for the one-pipe steam system. Everything is done locally, except for like the little bullet-style vents. Those are imported. We do not do those, but everything is done, and one of the advantages of our unit is once the unit is on, you don't have to change the unit for the size of balancing. All you have to do is change the little cap on top. And one of the things with our unit is just by changing it, the cap alone, you don't have to be, re-piping, putting Teflon tape, re-screwing on. You just change the little cap. And that's how you kind of balance the system within your house. Everything's kind of every home is a little bit different. Some of the balancing is, where somebody, the small room has to be a 4-size orifice, which means that's the smallest one we make. It doesn't necessarily have to go that direction. Some of it's strictly comfort. How do you feel? Do you want it 68? Do you want it 74? Do you want it, every room, somebody likes it a little warmer than others. You got an apartment, everybody's cold all the time. So you have, they just want the most heat you can have. And sometimes given that particular tenant a lot more than they want, it's kind of balancing the rest of the apartments. But what our unit does, and why it's here, is you only have to change the cap. So I guess that is more than, by changing the cap alone, you don't have to change the whole vent. And that's what kind of makes ours unit a little bit unique. Ours is, they say it's one of the quieter ones because, with the other style, it's alcohol-based, where you'll get the clicking sound or ours is kind of a gradual. It's actually done by a bimetal on the inside, a thermostatic bimetal that'll open and close the vent. And by having the larger vent size, like say we call it the D, what that does is allows it to stay open longer, to let more steam out, to let more heat into your radiator, before it shuts off and reaches the temperature that you're looking for. So I'm sure most of you here it's a matter of question balancing your system, or why do I have water? Why do I have, why does my system not, half the unit gets heat, half the unit doesn't, the radiator, which is a common problem, which, unfortunately it's not the vent itself, but it's other issues, which that's where Frank will definitely have answers for. So I guess more than anything, if people have questions. Yes.
So is there a correlation between the temperature that's going to be in a given apartment and the size of the orifice? The problem I have in a 20-unit building, a couple of the units are just hotter than hell, and the majority are kind of okay, and then there's some that are cold. I imagine the cold one might be air infiltration or whatever, but for the hot unit, should I just simply stick in a whole bunch of your number 4s?
I would go with the smaller, yes. Because you can always go bigger, you can only go.
So there is a correlation between
Oh, definitely.
that. Yeah, okay, all right.
When you're trying to balance apartments, what's the range of orifices, caps that you have, and how much are the caps?
I don't know what they actually charge for the caps, you know, directly. He could,
Caps are only 99 cents. That's all they are.
So do you have to keep a bunch of different size caps if you're balancing your apartments?
well,
To try this one, then we'll see. Maybe I want it a little more. Then you have to put another. Then you put another one on.
right, but yes, and you can also, I don't know if you sell them 5-packs.
We can also order those.
Event. And I mean, it's a cheap little thing, and when you change out units through years, it's usually what goes bad is calcification or something, that they start getting a little clogged up over, you know, a dozen years or so. Don't save the cap. That's what most people do.
Okay, thank you.
If somebody takes the cap off, what happens? If a tenant takes the cap off and just
Usually if a tenant takes the cap off, and what it does, it'll make it so it's, basically you're getting the most heat you can get out of it. And that's a good way, if I was a tenant, to get your unit warm. Some people do, to stop that, put a little crazy glue on it or something. I mean, that way you can still break it loose, and
they just can't do it with their hand?
yeah, because that's a common problem,
Okay.
very common.
Would you do a quick demonstration of cap change?
Sure. I might need some help with this. My fingers aren't real good. You gotta let.
Use adjustment.
Adjustable roll valves in the back. We have those.
So, there's a threaded part on top. It's as simple as taking the one out and then just threading the other one out. That easy. Yeah. So if you have an issue in with one of the apartments and somebody's complaining, you'll just take a look and see what you got on there. That's a number 5 I just put on there. The numbers are right on the top. And basically, just if you want to increase the heat, you drop down to a number 4, correct?
Opposite.
Opposite.
Larger.
Number 6.
No, go bigger, yeah.
Go bigger. So you'd increase and take this one out, but I'd save it because it can be reused somewhere else if you need to, and then just thread it right back in. And as Warren mentioned, obviously, if you want to prevent your clients from tapping these out and taking them out without your approval, just put a little dab of super glue right on the thread there, thread it in, and they're gonna have a hard time getting that out. So, but very simple procedure.
A common question we get at the factory is sometimes they get them at where this is, screwed up, sitting up a little bit. They say, oh, what should I do with it? It's going to work like this. As long as it's in place, it's going to work whether it's a little up or all the way down. It's all based on the hole size. That's why we kind of sell them like we do, so people can interchange them. And, I'm not going to say everybody likes it, because some people like it to where they just can't do anything with it, but that's what makes ours a unique, because most people's are fixed size, so you got to go out and buy a new one. Questions?
Any questions? Any specific questions about anything? Well, I think that before you can actually attempt to try and balance the steam system, you have to have a basic overview or basic understanding of really how these systems work. First of all, if you have a steam system, either heating your house, your 2-flat, your 3-flat, your 6-flat, or your 24-unit building, most often those buildings are not going to be built in the 60s or the 50s or the 70s, and certainly not in 2016. A lot of those buildings, especially if it's a Chicago building or Evanston, those buildings could be 80 years old, it could be 90 years old, it could even be 100 years old. And if you had a building that was built 100 years ago, and it was designed to be heated with steam, in other words, a central boiler heating this particular building, and each one of those units, be it some kind of radiator or some kind of termination unit, it was designed with a big, huge, massive boiler that produced a lot of steam. And the piping also corresponds with the size of that big, massive, maybe 90 or 100-year-old boiler when it was first put in. So you had a big boiler, you had a big oversized piping that required a lot of venting. Also, in order to turn that water into steam, required some fuel to fire it. And originally that fuel source was coal. And that coal was either stoked by hand by a stoker, which is a person, or some kind of mechanical stoker. So what you were getting was, you were getting a very slow, consistent fire in that boiler that turned that water to steam, and it slowly passed through that big, oversized piping and slowly filled the radiators. And it gave the vents, be it the main vents or the termination vents, which are these here. This is an example of a main vent. It gave it a lot of opportunity to push the air out, because it wouldn't be unusual for that boiler to be firing for 8 hours just to be able to slowly heat up those buildings and each one of those radiators and each one of those apartments. Now, since those original boilers were eventually converted from coal to oil, completely different burn. You say fire is fire. Well, fire is fire, but it's like, think of it as a hot fire versus not quite as hot a fire. So you had a different kind of system with those conversion burners using oil. And then those were replaced with a gas conversion boiler, which is another kind of fire. So what you're doing now is you're converting that water to steam a lot more rapidly, and now what's happening is it's coming up very rapidly, driving itself at high velocity through that oversized piping. Oftentimes doesn't give those vents the opportunity to slowly, to evacuate the air so that you can actually, so that piping and the termination units, which is the radiators, can actually fill with steam. So it's important to understand what you're dealing with. Even if you have a brand new boiler, it's very likely that the piping may be the original piping. So that's why if you're running into problems trying to vent the air out of the system, which means trying to balance the system, it's not you. You know, it's a difficult thing to do. It's really difficult to do. Because when they designed these heating systems for these 2 flats and 3 flats and 6 flats and single family homes and big buildings, those guys really knew what they were doing. These were boiler guys. And this is all they dealt with was steam. They didn't deal with hot water, which is hydronic. They didn't deal with anything other than steam. These guys were professionals, and this is all they did. Now, a lot of those professionals are now retired, or maybe they're not here with us anymore. And now there's a new generation of people who are equally smart, but they're dealing with something that was installed 80 years ago, or 90 years ago, or maybe even 100 years ago. So the balancing is very difficult for them as it is for you. One of the things which is, it's really a fallacy. What happens is the only reason why you have a boiler in this building or in your house is to provide comfort for you. And what happens is the way that you keep from freezing and you're comfortable is that termination piece or that radiator heats up adequately that you're comfortable. If you're comfortable at 68 degrees or you're comfortable at 70 degrees or 72 degrees and you touch that radiator and only one section is warm, or it doesn't even feel like it's warm, if you're comfortable, then the boiler is doing its job. The vent is doing its job, and the radiator is doing its job, as is the steam. So that whole fallacy of trying to walk up to a radiator and say, there's 10 sections here, or there's 20 sections here. Why is this one warm, and this is not quite as warm, and this is kind of cool, and this is ice cold here? There must be something wrong. There probably is nothing wrong whatsoever. If you're comfortable and you've reached temperature, that's all that counts. Everything else is superfluous, doesn't mean anything. If you're comfortable, that's all that counts. Now, when you talk about steam, you have steam and you have air in that piping. What happens is air is the enemy of steam. if there's air locked in the system anywhere, if it's locked in the piping, if it's locked in the radiator, if it's locked in the vents, if it's any of those places, it's your enemy. It will not allow the steam to be able to fill that space. So the most important thing for you to do is to make sure that there's nothing in the way of that steam. Most of the time, it's air, and that's why we have vents. We have vents at the termination pieces, which are the radiators. We also have main vents, which are located on any of those horizontal runs that are feeding it. And those are equally important. Everybody concentrates on the vents at the radiator because that's what you see. But there's all those hidden places that are equally important. And those are the main vents. The main vents and all are really just the big brothers of these here. You can get vents like these here, which you put on the main. You can get bigger ones than these two, which could be 4 times the size of this. Those you have to have on the main, and those have to be operated, because if those are not operating properly, you can forget about trying to get steam and venting it properly out of each one of those radiators, because it's not going to happen. And the location of these here on the mains is also very important. Oftentimes you will see a T at the end of a run, and you'll see a vent at the T at the end of the run. Maybe one of the worst places you could ever put it. That vent has to be approximately 15 inches from the end of the run, and it shouldn't be sitting on the top of a T either. It should be elevated 6 inches above it to be able to operate properly. And the reason for that is, there's a lot of reasons, but the main reason is when your boiler makes water and turns water into steam, then drives it down those mains, then goes up the risers, then fills the radiators, then you've gotten the temperature of the heat satisfied. That steam now will turn back into condensate and has to work its way back to the boiler. As it works its way back to the boiler, you have to make sure there are no obstructions. And one of the ways that if that is coming down too quickly, what it'll do is it'll clog these here, and it will prevent these from working, because you will actually flood these. And you don't want to flood these, because they won't work then. They won't work. Talking about condensate, we did discuss this at a previous class, but not only is air a major enemy of your steam, also the condensate or water is too. So if you have a radiator has a pipe coming out. We're talking about one pipe system to keep it simple. Pipe is coming up, and that's going to be supplying steam to that radiator. There's typically a valve there. That valve is a steam valve, which can shut it off 100%, or you can modulate it. Now, should you modulate it? No, you should not. It should either be all open or all closed. It's probably smarter to have it open all the time. All the time. That radiator, which is, let's say it's a rectangular piece like this, and if the valve is over here, that radiator should be slightly pitched so that when that steam turns back into condensate and cools, that condensate, which is now sitting in the bottom of the radiator here, can actually go back to the valve, go back down, and if it's piped right, there's no 90s below here. There's actually 45s like these here. And that'll be your drip leg that goes back and delivers water back to the boiler. There's also should be about a minimum of about 27 inches from the head of the boiler here and where that pitch is coming back to be able to make sure that you get all that condensate back to the boiler. And your boiler man, your professional boiler person, will be able to discuss these things called a Hartford loop and the proper kind of boiler protection that you need for your boiler. But it's very important that the vent is, first of all, the vent is on the opposite side of where the valve is. You'd be surprised how many times you'll go into a place and somebody was they're doing the best they could. They found a radiator, somebody said they were cold, they threw the radiator in, the vent's on the wrong side, the valve's on the wrong side, and the vent isn't doing anything because it's on the wrong side. You're better off not having any vent as opposed to having it on the wrong side. And you'll see that. And somebody will actually say, that's the way we do it. Well, I don't know where you do it like that, but it can't possibly work any place on earth. It just can't work like that. So you got to make sure that the vent's on the right side, the valve should be fully open, maintain pitch, and don't forget your boiler, no matter if it's 80 years old or 8 years old, when they made that boiler, that's that big piece of iron. They had to drill holes in it at the factory. They had to tap it. They had to do things to it. Now, there's oil in that boiler. And that oil gets a chance to meet with the water and with the steam and everything else that's been in those radiators for the last 80 years, turns into sludge. It has every opportunity to build up in the bottom of those radiators. So if you have a radiator that never heats up, no matter what you do, the pipe coming, the riser coming out of the floor is hot as can be, the valve feels hot, the outlet side feels hot, and nothing is happening, and you know there's no water in it, or you think there's no water in it, because the radiator isn't hammering and jumping up and down and screaming, then you could have sludge in it too. There could be that much sludge in the bottom. How do you fix that? It's pretty easy. It's just grunt work. What you do is when there's not a head of steam, you disconnect the radiator, you haul it out on a porch, you pitch it back, you back flush it with a hose, get all that sludge and everything out of it, hopefully reconnect it, and you're good to go. So sludge is also can be a problem too. And I've heard people say, you'll never find sludge. Well, you may have never seen sludge in your house or your building, but everybody else has found sludge in a radiator at least once. At least once. So we know what we're dealing with. We're trying to make steam. We probably have oversized piping. We have to have main vents that work and they're properly installed and in the right location. We have to have the right risers going up. You have to make sure the valves are working. You can grab a radiator valve and say, turn the knob, and you can watch that stem move up and down and it's doing everything. That doesn't mean it's working. Because it could very easily, they didn't grow it that way. It didn't come out of the ground. It's made out of pieces. So you've got that stem that's down there. You've got a disc on the bottom. You have every opportunity that thing for it to rust apart, fall apart, have that steam just be stuck down there in the bottom position, and there's no way that steam has enough strength or pressure to lift it up. So if you have a valve that's 30, 40, 50, 60, 70, or 80 years old, I think it's about time to invest in some valves and change some valves. And when you buy the valve, it's going to come with a spud too, and we sell them here. They're very inexpensive, but they work perfectly. And also, when you look for vents, when you buy vents, you say, what's a vent? Well, a vent is a vent is a vent. Well, a vent is not a vent. There's vents that are made all kinds of places. And there's vents that are made right here in Chicago. American manufacture, American workers, American know-how, American design. You can buy an American valve because we still do everything better than anybody else in the world. There's no doubt about it. We make everything better than anyone else in the world, including something fairly simple like a steam valve. If you buy these valves from us, or an American-made valve, you can be guaranteed to get a good product. If you buy something else, I don't want to say you deserve what you get, but you'll get what you deserve. That's about it. So.
I do believe we, at this time, are the only U.S. manufacturer of steam vents. I think everybody else is importing.
And when you buy these vents from us or you buy the valves from us, you're going to run you or your installer, be it your fitter, your plumber, your engineer, who's ever doing this for you, he or she is going to need certain things. Don't be surprised when you try and change the vent that the tapping is light, it's sloppy. You may have to retap it. Taps cost less than $10. We have the taps here, they're 1/8-inch taps. Don't be surprised that when you take the spud out, you got to clean up the threads on the radiator. We sell those taps here. Be there 1 inch, 1.25 inches, occasionally 1.5 inches, 2 inch. We sell those here too. So anything that you need, we can help you with. The only thing we can't supply you with is the labor, but we can do everything else.
There is one real common problem that people call me all the time on. It's, I'm getting water coming out of my vents. And it's just like everybody. And a lot, I would say probably 70% of the time, it's a boiler pressure issue. People have a tendency to, I need more heat, turn up the pressure on the boiler. It actually kind of works just the opposite. Most boilers probably work at 1/2 pound to maybe 3 pounds, depending on size of units, obviously, but it's not, a lot of times you got too much pressure, so you're not allowing that water and steam to pass through.
What Warren said is absolutely accurate. The worst thing that you could ever do is to, if you're having a problem or you have like one unit in your building, or you're saying I can't get some heat in there, is to boost the boiler pressure, because not only is it won't do any good, it actually is counterproductive. If it'll do anything, what happens is those radiators and those termination units will not be able to keep up with that. It's almost always a venting problem. It's never going to be a pressure problem.
Yeah, I was wondering if you could speak on like knocking in the pipes and what causes that.
That's an air thing, and it's basically air in the pipes.
Yeah, if you have knocking in the pipes and all, it's like we mentioned earlier and all. What happens is air. There are certain enemies to steam. Air is one of them, and water is the other one. So what happens is you have somebody who's saying, you know what, my bedroom is so hot. It's just so hot. So what they do is they close it. They touch the radiator. They say, God, it's hot. They turn the valve. Now what they've done is they lock that steam in that radiator. It has no opportunity to work its way back, because unlike a hot water valve, a steam valve is a complete stop. That steam now turns into condensate. Now there's water sitting in the bottom of the radiator. Then at 4 o'clock in the morning, they say, I'm a little chilled. What they do is the boiler's still firing because it's heating the rest of the building or the rest of the house. They open up the valve. They want to warm up. Now there's already steam in that horizontal, and there's steam in that riser and at that valve too. Now that steam rushes out once it filled the radiator, and what does it hit? It hits the water. That's when you see the hammer, or you can hear the hammer. And it's not unusual to see the radiator move. That radiator will move. You can actually see it jump. So that's what that knocking is. Now typically if it's at a radiator, that's where it is. If it's doing something in one of the horizontals, one of the main runs or one of the branches, then you know it's a problem that you're locking water in there, and that's usually a steam problem. That's a main vent problem.
This is when you would want it like 15 inches out.
15 inches from the end of the run, and you should elevate it 6 inches above that T.
Can you repeat the part about 27 inches real quick?
Well, actually, what happens is it's a little bit more detailed than that. But what happens is at the boiler, depending on where the size of the boiler is, what happens is if you're starting here, you're starting at the ceiling, you typically have you're supposed to have at least 27 inches of pitch starting at the top and working its way all the way around the perimeter and work its way back to the boiler. And that pitch, anything is better than nothing. But if you could pick up as little as even a half inch a foot, even if it was a 1/4 inch a foot, anything would help. As long as it isn't line level or back pitched, because you will lock condensate in there. The larger the piping, the more problematic. You would think the smaller the piping, the less problematic, but it's the larger the piping, that's the problem.
Hey, Frank.
Is that the same tilt that you need for the radiator? A half inch a foot?
If you could get a half inch a foot, that's a lot. That's a lot. Anything is better than nothing. I've never really seen half inch a foot except in a very small radiator. Typically people are doing a 1/4 inch a foot, and that's more than enough. But it just has to be pitched back towards the valve. In Chicago, a lot of these buildings have oak flooring throughout the unit, maple in the kitchen, and usually tile in the bathroom. Those big heavy radiators, they stick underneath the windows with that beautiful oak flooring that was put in 80 years ago. Those radiators have dropped. They've dropped a lot. That's why you can see those legs just kind of like sinking right into the floor. Also, big radiators are made out of sections that are put together with typically 4-threaded rods, with nuts and bolts, with push nipples. Don't be surprised if you look at that big radiator and you see a big sag in the middle. You see it because there's usually legs on the left side, right side, none dead center. And you'll see a sag in the middle. If you see a sag in the middle, don't be surprised if you don't have some sludge in there.